Okay, now we're going to talk about the idea of something that's called a limit. Most limits that we deal with can be viewed as a numerical limit of values of functions. Intuitively, you know what a limit is. Okay, limit is something that an expression approaches to at a particular x value. A calculator can suggest a limit. It could give us an approximation for what a limit is. And calculus can give the mathematics for confirming the limits analytically. Okay, analytically, again, we're talking about algebraically, using calculus, using the rules of calculus. Limits give us a language for describing how the outputs of a function behave as the inputs approach some particular value. Okay, so take a look at this notation right here. The notation limits of f of x as x approaches c is equal to L is read, okay, exactly how I read. The limit of x as x approaches c is equal to L. The notation means that we can force f of x to be as close to L, the value L, as we wish, simply by restricting the distance between x and c. Okay, that distance x and c, we used the letter h. We're using the letter h to represent that, or you could think of it as delta t or delta x, but not allowing x to equal c. Formally speaking, that x value is not equal to c. So example of limits. Okay, take a look at this table. Okay, so we don't know what the actual expression is, what the actual function is, but you're given the table values. Okay, if you take a look at this, as your x value is getting close to 0, as x value approaches 0, which is here, what is the limit of this function? What do you think the limit is? Okay, even though at f of 0, what we have is an error. That doesn't tell us much. Okay, but if you look at the pattern, okay, from the left side and from the right side, what number are they approaching from the left side and the right side? Okay, both of them, okay, you could argue that the limit of this is 1 just based on the data that you have, based on the pattern that you have. Okay, take a look at the table below. What is the limit of the function just based on the graph? Okay, and it gives you the equation. It gives you the function too, the function rule too. But what's the limit as the x value approaches 1? Okay, again, we're not necessarily looking at f of 1. Okay, sometimes we could use f of 1 as a limit, but we're not looking at f of 1, but we're looking at the limit of f of x as the x value approaches 1. So again, once again, my recommendation is take a look at to look at the pattern from the left side and from the right side. What number is it approaching as, okay, the x value gets close to 1 from the left side, both from the left side and the right side. And the answer for the first one would be 1. I'm sorry, not 1, but the y value is 2. So the limit is 2, okay, for the first picture, first graph. For the second graph, again, you have a piecewise defined function with a whole at x equals 1, but then it's defined somewhere else. Okay, your f of 1, or in this case, g of 1, is defined to be 1, but then that's not the limit. Okay, again, take a look at the trend, take a look at the pattern. Okay, from the left side and the right side, the graph, your function, is approaching the y value of 2. So that will be your limit. Okay, so we could say that the limit of g of x as x gets near 1 is still 2, even though it may not be defined at x equals 1. Okay? The third one is the easiest one. Okay, third one, your limit matches the defined value as well. Okay, so at x equals 1, your y value is 2. Not only is h of 1 equals 2, but the limit of h of x as x gets close to 1 is also 2. So notice this is a scenario where the defined value at that x value, okay, matches the limit value itself. Okay? And we will talk about this in more next lesson, 2.2, when we get to the topic of continuity. So this is the idea of the limits. Okay, and then so if you look at some of my example right here, if you look at 2 examples right here, okay, this matches the example that was given to you in example 4. So before knowing any rules or theorems of calculus, you could also try to get this by using, or you could try to get this value by having the graph of these expressions. You could make this as a function, f of x equals x squared minus x squared multiplied by 2 minus x. Graph that and see what the y value is, or see what the limit, see what the y value approaches from the left side and the right side as the x value gets close to 3. Um, Same thing with this one. Okay, try to do this by graphically, and then we'll talk about it.